This video addresses two chapters in one. Lessons 43 and 35 talk about circles, tangents, chords, secants, and so on. And what I want to do is explain how to use the formula for area of a sector, and the length of an arc. So those are two basic concepts that this chapter addresses. So the first thing we want to establish is the area of a sector. Well, you might be asking, what is a sector? Well, the sector is basically that right there. So the area of a sector would be pi r squared, the measure of the angle that you're given, over 360. That's the formula. So when they give you m as 201 and r as 24 millimeters, all you need to do is plug in what you're given. So pi is 3.14, we'll use that as pi, and then r is 24 millimeters, so that's squared, and then m is 201, all over 360. Next thing you do, of course, is you simplify. The top is 3.14 times 24 squared times 201, all of that divided by 360. So basically it becomes 576 pi times 201 over 360. And then we go ahead and simplify that with our calculators, and we get A is equal to 1009.8 millimeters squared. All we did was we plugged in our value for m, we plugged in r, we solved using basic principles of math. For the second problem, we're given the area and we're given the measure of the angle. We know that the formula is pi r squared m over 360. What they want us to find is r. So there are two ways to do this. You can go ahead and plug in the numbers you have right away, or you can solve for r first, then just plug in what you have. So basically r becomes the subject of the formula. Right now a is the subject of the formula. We need to make r the subject of the formula. So how do we do that? What we do is we go ahead and start with, so a is equal to pi r squared m over 360. We'll go ahead and try and move everything over to the left side. We multiply both sides by 360, and we get 360a is equal to pi r squared times m. The next thing we do is we divide both sides by the things we don't want on the right. So we don't want pi m, and so we divide both sides by pi m. We now have r squared is equal to 360a divided by pi m. Well, we're not looking for r squared, we're looking for r. So we go ahead and take the square root of both sides. So r is the square root of 360a divided by pi m. That's r. And we're done at this point with getting making r the subject of. When we make r the subject of the formula, that's what we get. So we go ahead and plug in 172 for m. We plug in our value for pi, 3.14 is what we're using now, and the area is 95 feet squared. We'll go ahead and plug those in, and that will give us r. Remember, when you are given certain things and you don't have the other things that you want, you make them the subject of the formula. So, for example, in this problem, they want you to make m the subject of the formula, because they're asking you for the measure. What is this angle? Right now it's called m degrees. The length of the arc is 2 pi r times m over 360. Notice that the length of arc and area of sector formulas are similar to the circumference and the area of a circle formulas. They're similar. The difference is that it's m times m over 360. The interesting fact is, if m is 360, then you would just be finding the circumference of the whole circle. At this point, we're looking for m. So we do something similar. We're trying to get rid of everything on this side, bring it over to that side. So we multiply both sides by 360. We get rid of the 360, so we get 360L is equal to 2 pi r times m. Remember, we're trying to make m the subject of the formula. So we divide both sides by 2 pi r. And so m is equal to 360L over 2 pi r. Go ahead and plug in what you have. You have L, which is 18 cm. You have R, which is 16 cm. and pi 3.14. And you can solve for m. That tells you the degrees. And when you do this problem, you should get, for m, it should be 64.5 degrees. For the second one, when you solve, you should get 7.96 feet for the radius. Let's do one more problem and we'll stop there. This is a circle. This is called the diameter. You go from one end to the other end to the center of the circle. This is called a chord. From one end, from one point on the circle to another point on the circle. And so what you want to do at this point is, the chord is 11 centimeters, we would say. And the diameter is 22 centimeters. They're asking us to find this distance right there. They call it the distance from the center of the circle to the chord. And so what you need to realize is, at this point, you can't do much until you set it up and get a triangle, and then you can solve for it. Notice that this point to that part is the radius. Radius is when you draw a line from the center to any point on the circle, or half the diameter. And so the radius is 11 centimeters because it's half of the diameter. So this part right here is 11. This right here we don't have. Let's call it y. Now this part right here is 5.5. How do I know that? Because when the diameter goes past the chord in the middle there, it bisects it. And so we get 5.5 and 5.5. Because this is equal to that. That's one of the theorems discussed in lesson 43. So go ahead and you basically have a triangle right now. 5.5, 11, and so 11 squared is equal to y squared plus 5.5 squared. That's how you set it up and you solve. I was asked if it matters what is what, and yes, the hypotenuse is always the c squared in a sense. If it's set up as a squared plus b squared is equal to c squared, the hypotenuse would be considered the c squared. Go ahead and solve for y, and you get your answer, which will be 9.5. And that's all for these two chapters.